Hi, this is Professor John Lamb, and welcome to Manipulations in Mathematics. Here's another video on color tiles. I'm sorry, not color tiles, two-color counters. Again, these are counters, and they're very helpful in building students' understandings of being rational counters and also early understanding of addition. You can also do early understanding of subtraction with these, to where we have three yellow and two red, where we understand that a red and a yellow, when paired together, they make 0, so they go away. A red and a yellow, when paired together, make a 0, and they go away. So when I have 3, as I did earlier, 3 yellow minus 2 red, therefore that's going to make 3 yellow plus minus 2 red, or take away 2 reds. They pair up, make zeros, and they go off the board, and we're left with 1. You do this early on with pairing up, and then later with your older students, when they're understanding negatives, this becomes positive 1 plus a negative 1 does go to 0. So positive 1 and negative 1 equals 0, which is why they go away. Now, early, when you're dealing with very young students, you want to talk about pairing them up, and then they go away. Because we are subtracting, we have 3 subtracting 2, or taking away 2, the takeaways pair up, and they take that away. So 3 take away 2, the red pairs up and takes it away. That's subtraction, and you're left with 1. But as I said, with older, you want to deal with negative 1 and positive 1. So we understand that when we're dealing in our older groups, where subtraction, 3 minus 2, is really 3 plus a negative 2. So here we have 3 positive counters plus 2 negative counters. So 3 plus negative 2. Which is 3 minus 2. And it's still the same concept of negative 1 and positive 1 paired to give a 0, and then they go away, and you're left with 1. Okay, so that's one way that you can do some more counting and subtraction with two-color counters. But we also want to deal with probability with two-color counters. What is the likelihood or chance that you are going to get kind of the theoretical probability? Now, early understanding of probability here is this is a two-color counter, so there are 2 colors. There's a yellow and there is a red. So when I flip this coin, I'm going to get one of the other. I'll have a 50% chance, 1 out of 2 chance of getting a yellow. I also have a 1 out of 2 chance of getting a red. So therefore that is a 50% chance. Well, if I have 6 color counters in here, and I put 2 color counters, and I put them in a cup, and I shake the cup up, and then I roll it out, what I should expect is that I'll get 3 red and 3 yellow. That is 50% chance. But then when I spill it out, of course this first example done on video is exactly that. 3 yellow and 3 red. I do it again. I shake it up, spill it out, and it happens again. So as I am doing this video, it looks like theoretical and experimental are always the same. Well, I'll keep doing this until I can disprove that theory, that experimental probabilities always have. I'll shake them up a little bit more, spill them out, and here we go, a nice example to where we have only 1 yellow and I have 5 red. So really, this does not illustrate the theoretical probability of 50%. It's actually 1 out of 6, so about 17%. So you want students to do these activities many times, or experiment many times, until you can see that the more you do, here's a 4 to 2, the more you do, the closer it will come to being that theoretical probability. But you can't just take one experiment and then assume it's going to be the theoretical probability. So here's two color counters and early activities dealing with probability and then of subtraction. Those are good activities to do with these two color counters.